right, here we go. We are on Unit 2, Day 8, and we're going to be talking about a couple of theorems today, but I want you to start off on page 238. Okay, so 238 used to see these problems right here. We're going to do 10, 11, and 12. All right, if you know how to do them, go ahead and do them and then check back to see what we got as our answer. Okay, number 10 says the polynomial function, right here, b of x, has a known factor of x plus 2. Rewrite b of x as a product of linear factors. Now, you could do this and you could actually divide by -2, all right? Or like synthetic division, we can do -2, all right? Remember x cubed, x squared, x, and then our constant, 1, 8, 5, and -14. All right, bring down your 1. -2 times 1 is -2, and that gives me 6 when I add it. -2 times 6 is -12, and when I add it, I get -7. And -2 times -7 is +14, and when I add it, I get 0. If it's a known factor, it should be 0. Okay, so now remember, if this is x cubed, this is x squared. All right, that's x. All right, and then that's a -7, so that's going to be plus. Okay, so see if we can continue to factor this. What are the factors of -7 that add to 6? All right, well, that's going to be a +7 and a -1. All right, so our factors are x plus 2 that they told us, x plus 7, and x minus 1. Now, that's how you do it without a calculator. All right, if you got a calculator, you could just graph this from the beginning. And if you did, a great job. All right, so here, let's plug it in. X cubed plus 8x squared, make sure you're putting it in there correctly, plus 5x minus 14. All right, so there we go. And all we have to do is look at the roots. X minus 7, so x plus 7 is a root. Okay, I see -2. Well, that's the one they gave us, x plus 2, think opposite. And then this one is 1, so opposite would be x minus 1. All right, so if you just graphed it, you could find all the linear factors pretty quickly without doing division. All right, this method would be if you didn't have a calculator. All right, number 11. Is this the graph of a g of x right here, or is it of h of x? Well, pay attention to the roots. Well, here I have a root at -2, so x plus 2 should be a factor. All right, here I have a root at 1, so opposite, x minus 1 should be it. But what's special about 1? Remember, if it bounces off the graph like it does here, that it's a double root, so we should put a square. Okay, so which one's correct? It's going to be g of x. All right. If you want to explain how you know, you can. You can make little notes. This is going to be a double root right here, and this is why you need the square. All right, let's move to number 12 on the next page, on to page 239. All right, so here we go. Here's number 12. All right, technology required. We want to graph this function. Okay, so I'm going to start by graphing it. All right, and so -x raised to the 4th minus 2x cubed plus 11x, oops, I didn't put the x, squared, oops, all right, plus 12x. All right, so here we go. Use interval notation to describe where the function's increasing. We've talked about increasing before. It's when the graph goes up, but however, start on the left-hand side. Okay, so here, and think about you drawing it. I'm going to zoom out of this and kind of move it. So if I was drawing it on the left-hand side, you can see my cursor. I start from here and I go up, and I keep going up and I keep going up to this point right here. Okay, so here, because there would be an arrow down here, I'm starting at -infinity. All right, and it's increasing. Okay, it increases, and remember we're using the x value, so I'm not going to use 36, I'm going to use -3. It increases all the way to the x value of -3. Well, then what does the graph start doing? It starts to decrease. Well, if you notice in part B, it's asking for decreasing. So let's go write that. So from the x value of -3 all the way down to this minimum right here, all right, it's going to decrease. Well, also remember, this says -0.5, but please know that's -1/2. All right. And then after this point right here, I start to increase because I keep going up. All right, so I all the way to that maximum. So I'm going to put a U because I have a second part that's going up. So it's from the X value of -1/2. All right, and then all the way to the X value of 2. All right, and then it stops decreasing. I mean, it starts to decrease right here at the value of 2. But this keeps going on, and this will keep going on. It's actually going down and out. So it's going to hit all the X's over here, all right, to positive infinity. So make sure you know how to write interval notation and make sure you know about increasing and decreasing. The other things we've talked about is positive and negative as well. So if you could pick those out, you can pick those out as well. All right, so let's move on and let's go ahead and get into our lesson for today. All right, now the first thing we want to do is we want to simplify something that looks like this right here. All right, simplify. Well, what does it look like we're going to do? Well, it looks like we're going to divide, okay? Can we use synthetic or do we have to use long? You want to use synthetic, go right ahead. I'm going to do that. If I'm dividing by x minus 3, what goes in the box? A positive 3. Now be careful before you write the numbers. Long division, you would catch it because you leave the x's in here. But here, you got to make sure it says x cubed, x squared. I need a 0x. All right, so, and then I have my constant. So my coefficient's 1, then it's -12, then it's 0, and then it's -42. All right, bring down your 1. 3 times 1 is 3. And this gives me -9. 3 times -9 is -27. And when I add it, I get -27. 3 times -27, because right now I don't have my handheld here. So what I'm going to do is I'm going to say 3 times -27. If you want to put parentheses around it, you can. You get -81. Well, duh, I actually did know that. -81. All right. And then I add it. That's going to give me a 3. That's -123. All right. This does have a remainder. Okay. And remember how we write this. If it starts with x cubed, we're going to say x squared. Then we're going to say x. Then when that's our constant. And our remainder, we do -123 over what we're dividing by. Okay. Now let's move on to number 2. This is a different problem, but there are some similarities. Look right here. Okay, f of x, that's what was on top of here. All right, so let's just go with the flow. It's asking us to find f of 3. All right, x cubed minus 12x squared minus 42. So what, whoops. And so every x, basically, we're going to put in 3. So I'm going to erase my x's, and I'm going to replace it with 3. Just make sure you put parentheses around them. Now you can plug this in right here. Okay, so when I plug it in, I'm plugging in 3 cubed. Oops, hold on, not that. Okay, 3 cubed. All right, minus 12, and then 3 squared. Okay, minus 42. All right, and it comes out to be -123. The other way you can do this is you could actually plug in f of x equals x cubed minus 12x squared. All right, minus 42. And then if you say f of 3, it comes out with that value. So that's another way to do it as well. All right, so I want you to look at this, and what do you notice? Well, these were the same. Well, I put 3 in the box, and they wanted me to plug 3 in. What did it come out as? -123 here. Well, what is that the same as? It's the same as the remainder. Okay, so I see -123, but remember, this is our remainder. Okay, all right, so what does this mean for us? Okay, what are we doing here? Well, there's something called the remainder theorem. All right, the remainder theorem says this: P of x equals, all right, x minus a times q of x plus r, and r is the remainder. Basically, what this is saying, okay, if I have p of x, which is in this case would be x cubed minus 12x squared minus 42. It's going to equal and I'm trying to hold on, I'm thinking about something for a second. It's going to equal x minus a, which was x minus what do we divide by? X minus 3. All right, times q. All right, so if I multiply this, all right, by x squared minus 9x minus 27, and then add our remainder, so negative 123. All right, that's what that means right there. Okay, where r would be our remainder. Now, what I did up here in number 2, we call this synthetic substitution. And what synthetic substitution, and this is what I'll deal with more, is synthetic substitution and the fundamental theorem of algebra. But the synthetic substitution says this. Basically, if I'm dividing by x minus a, okay, if I'm dividing by x minus a, all right, let's just say p of x is divided by x minus a. In this case, I did divided by x minus 3 up here. Then if I do p of 3, if I plug p of 3 in here, all right, and it gives me 0, then x minus a is a factor. Now, my question is, was x minus 3 a factor? No, because it came out as a number. So basically, I didn't mean to put 3 here. I meant to put a. P of a equals 0. Now, if P of a, if I plug a in, and I don't get 0, and I get some other number, this number is the remainder. Do you see how it came out as the remainder here of negative 123? All right, so we can use synthetic substitution. It's just an easy way to determine, do we have a factor? Now, can we find out what we divided, what it comes out to be? No, we can't, but we can determine what the remainder is going to be, and we can determine if it's a factor or not. All right, now another thing that we have is the fundamental theorem of algebra. Fundamental theorem of algebra, we've actually covered it, we just haven't used the name yet. It basically is the number of zeros. Zeros is the degree. Okay, this includes multiplicities or double roots and triple roots. All right, now let's go to page 244 and we're going to look at activity 1. All right, 244, let me get there. All right, and we're going to look at, again, activity 1. Activity 1 is down here. Now, this is going to be a good problem to use synthetic substitution for. All right, consider the polynomial function f of x, where u is an unknown number. You see u right here, real number. Now, x minus 2 is a factor. All right, that means if we know it's a factor, what we can do is we can do division. You could set up synthetic division, like put a 2 here, and then we can put, I'm not missing anything, our coefficients. Now, there's a u there, so we do u. And that's, you don't have to put plus 24, you can. All right, and think about synthetic division. All right, we would bring down our 1, and then 2 times 1 is 2. The problem is right here, when I go and add this, that's 2 minus u when I add it. That poses a problem, okay? We can still use synthetic division because if we know a factor, this is supposed to be 0, right? We can actually work backwards, and what's going to give us 0 is negative 16. Well, 2 times what gave us negative 16? It'd be negative 8. Well, wait a minute. What did we add to negative 32 to get negative 8? We'll just think about this. All right, that's actually going to be positive 24. All right, well, what did I multiply by this number down here to get positive 24? Well, 2 times 12 is 24. Well, here, what do I add to 24 to get 12? You would add negative 12. All right, and now look at it. I have a nut. So 2 times whatever this is supposed to equal the negative 12. And now I have an equation that I can solve. All right, minus 4. And we get negative 24 equals negative 16. All right, I had written this thing down here. I'm going to erase it. You can ignore what I wrote down here. All right, so here I'm missing my u. That's negative. That's a u. That is not a 4, by the way. So negative, divide by negative 2, and I figure out u equals 8. That's one way to do it. If you understand working kind of forwards and backwards with synthetic division. However, you can use that synthetic substitution. All right, if I know negative 2 is a factor, then when I plug p of 2 in, that means I'm plugging in 2 for every x. Don't miss one. If it's a factor, what's my remainder supposed to be? It's supposed to be 0. So there would be a 0 there. All right, and now I can solve. All right, so here this would be 16 minus 2 cubed is 8, so 8u. All right, 2 squared is 4, and 4 times 24 is 96. All right, this is going to be minus 64 plus 16 equals 0. Now, I'm going to do some math here. All these constants on this side, we can actually add together. All right, so if I add, let's see, I'm going to do 16 plus, I'm going to add that 96 minus the 64 and plus 16. So all those constants equal 64. So this negative 8u, all right, plus 64 equals 0. So now I can subtract 64. All right, so negative 8u equals negative 64, and I divide by negative 8. And guess what u equals? The same thing I just got a second ago. It equals 8. All right, so you can use either one of these methods to determine what that u value is. All right, I do have another problem of this on our worksheet. So I'm going to go to that worksheet. It's actually the one I erased just a second ago. I just have it on this worksheet instead. All right, so here we go. This time, instead of u, I put k there. K is like a common variable they use when we're missing something. All right, now this time, instead of us saying it's a factor, they actually gave us the remainder. All right, I'm going to use, now again, you can use synthetic division. 4 would go in the box, and it would be 4, negative 10, negative k, and 16. All right, if the remainder is supposed to be 68, we would write it right here. All right, I'm going to start out synthetic division. 4, bring the 4 down. 4 times 4 is 16. If I add this, I get 6. 4 times 6 is 24. And when I add this right here, it's 24 minus k. Now think about this. Now this one, k is a little further to the end, so it may be easier. 4 times this, whatever this is, I'm going to put that in parentheses. 24 minus k should equal, all right, is that right there? Okay, so I actually have this equation, 16 plus 4 times 24 minus k should equal 68. All right, 16 plus 96 minus k equals 68. All right, 96. All right, let me just do this real quickly. All right, what is 96 plus 16? It gives me 112. All right, so 112 minus k equals 68. Subtract 112. All right, so here if I take, what was it, 68 minus 112, and I get negative 44. All right, and you can see that right here, I can just change the signs, and k equals 44. All right, that's the longer way of doing it. To use synthetic substitution, we would plug 4 in for every x. And it should equal the remainder, which is 68. All right, so when I take this part, all right, it would be, what is it, 4 and 4 raised, hold on, 4 raised to the 4th, third, sorry. Okay, minus, and then it says 10, and then 4 squared. Now that negative K4, I'm not plugging in, I'm just doing all my constants, plus 16. All right, that equals 112. So all my constants equal 112. The only thing that wasn't a constant was this minus, that's 4K, equals 68. Oh, and by the way, I'm sorry, I messed up here. Let me go back. I should have distributed the 4 to here. So that's 4K. So that's 4. So really, when I divide by 4 or negative 4, K equals 11. I apologize for that. So K is actually 11, not 44. All right, so now when I subtract 112, 68, and you kind of see the same equation right here, equals negative 44. And when I divide by negative 4, you get K equaling 11 right there. So this one's a little bit simpler method. It's a little less math involved, but I do understand some of you understand the synthetic division better, all right, instead of synthetic substitution. But realize when you plug that number in, what you would plug in the box, it comes out as the remainder, so you can solve for that variable. All right, so 246. Let's go to 246 and let's look at this problem right here. Okay, so which of these polynomials could have x minus 2 as a factor? We're just hitting all these things. Now, I could use f of 2, all right, and I could just plug in 2 to each one of these to see which one's going to give me 0. But some of you are like, well, I could just use and plug in all these graphs. And yes, you can. Now, the faster you plug it in, x squared, okay, minus 7x minus 5. What you're looking for is if x minus 2 is a factor, what's a root? X equals 2. So that's all we're looking for. Is it hitting at 2? Nope. All right, so let's go do another one. Okay, so 3x squared plus 15x minus 42. Does it hit at 2? Yes, it does. So it's a factor. You can use division for this as well, if you would like. All right, I'm just going to continue to plug in the rest. You do it as well and see if you get the same thing as me. Now that one does not hit at 2 at all. All right, so let's see. All right, keep going. It does take a little bit of a second. The faster you put this in, the more times you put these in, it becomes faster. That's why I'm able to put it in so fast. Does it hit at 2? Yes. So x minus 2 is a factor. All right, I'm going to put in E. All right, 8x to the 4th minus 41x to the 3rd minus 18x squared plus 101x plus 70. Now remember, on the EOC, you're not going to have a teacher to help you and tell you what to do on the calculator. So make sure you're trying to use them. All right, 2 is a root, so x minus 2 is a factor. And lastly, let's look at x raised to the 4th plus 5x to the 3rd minus 27x squared minus 101x minus 70. All right, here, nope, not hitting at 2, so that's not a root. All right, and again, you can, if you have a calculator handy, you can do exactly what we just did. Otherwise, if you just plug 2 into each one of these, as long as it comes out as 0, that's your remainder, and that's what the answer is going to be. All right, move back to page 243. I want to recall some things, all right, from math 2. We're going to look at this bridge. All right, I know it says start the lesson with it. Well, we ended up in the middle. All right, what do you know this is? It's a quadratic, okay? Now, a quadratic, if you remember, has x squared in it, and it should have 2 roots, but I want you to look at this, what's happening. All right, here, there are no, okay, no, and I want you to add this word, real roots. Okay, now, this is a quadratic, so it's in the form ax squared plus bx plus c. All right. It should have 2 roots based off the fundamental theorem of algebra. The degree is 2. I should have 2 roots. Well, why isn't it showing it? All right. Well, because we actually have imaginary roots. Do you remember what imaginary roots have with them? They have I. You discussed these, and these come about in math too. All right. Okay. So let's look at this. The quadratic function, which was this graph right up here, can be written like this or this. All right. So use either representation to determine the zeros. I'm going to use this one. And I'm going to recall the quadratic formula. I'm just doing this briefly. So if you need to go watch a video on it, you watch a video on it. The quadratic formula is x equals the square root, or nope, negative b plus or minus square root of b squared minus 4ac all over 2a. I have a song for it. You can go look up a song. Go right ahead. And remember, a, b, and c. Your a is 1. Your b is negative 4. So this is going to be negative of negative 4 plus or minus b squared. So negative 4 squared minus 4. Our a value is 1 and our c is 13. All over 2a. So 2 times 1. All right, now this minus negative right here, it's going to turn to a plus. All right, now what's underneath the radical? Well, what is that? I'm going to plug that into my calculator. All right, so negative 4, make sure you put that in parentheses, especially since it's a negative. If not, you're going to come out with an incorrect answer. All right, 1 times 13. All right, it comes out to be negative 36. All right, underneath the radical is negative 36. And that's a 2. Now, if you remember anything about imaginary numbers, I'm going to split this into this right here. Okay, where does the I come from? It comes from the square root of negative 1. All right, the square root of negative 1 is I. That's where the I comes from. Now, what is the square root of 36? 6. All right, and now we can divide this. 4 divided by 2 is 2. All right, 6 divided by 2 is 3. All right, and here these are both imaginary roots. So we have 2 imaginary roots here. So if you know that there's 3 roots, okay, but you're only seeing 1, then a lot of time, and it's not a double root or triple root, a lot of times the 2 are imaginary. And the 2 roots are 2 plus 3i and 2 minus 3i. Like that. All right, so let's move on and let's go to page 248. All right, 248. Okay, we're going to look at activity 4 right here. We want to use Desmos to graph each of the polynomial functions and identify the number of real and non-real. All right, so I'm going to go here. Now, first off, how many roots should this one have? It should have a total of 4. All right, so here we go. X to the 4th minus x to the 3rd minus 9x squared minus 11x minus 4. All right, now how many roots did we say we were going to have? 4. Now let's look at these roots. All right, and I'm going to add some words in here. You have heard them before. I don't know if you remember them or not. These roots, we have 2 roots, negative 1 and 4. All right, but you said there should be 4 in all. All right, these 2 are called 2 real rational roots. Okay, now here, why are they real? Number 1, real you see on a number line. Okay, rational means it can be written as a fraction. Okay, and what I mean by that, like negative 1 is a fraction. It's negative 1 over 1, or 4 is a fraction, 4 over 1. Now, if you see 2/3, that's a fraction, that's rational. Okay, 2/3 is actually 0.66666 repeating. If you see 1/3, which is 0.33333 repeating. If you see 0.5, that's 1/2. It can be written as a fraction. All right, if you have any repeating decimals or decimals that end, they can be written as a fraction. Now, what about my other 2 roots? Well, we don't see them, right? Well, those 2 roots are imaginary. So we have 2 imaginary roots. All right, and look, that's a total of 4. The other ones, all we need to know for math 3 is to be able to do this. We don't need to be able to find all those imaginary roots and all the roots, but we just need to be able to identify. Okay, so let's move on to part B. I want you to start putting that one in and ask yourself, how many roots am I supposed to have here? All right, if you said 5, you are correct. All right, so let's look at this right here. Okay, so there's supposed to be a total of 5, but how many do I have? All right, you may have to zoom in here to make sure that's, because it appears to be bouncing off. All right, so right here, -3 and 2. But what's special about -3? It bounces off, so it's a double root. So -3 and -3 would happen twice, and I would have 2 also as a root. So I really have like 3 real rational roots. Okay, well, do I see any more? No. So I have 2 imaginary roots here. All right, for a total of 5. Count -3 twice into that, so then you can add those up all together. All right, now let's go and look at number 2. A cubic polynomial has one real 0 at -2. All right, and a non-real 0 at 1 plus 7i. Now, let's talk about imaginary roots. Imaginary roots come in pairs. What that means is you're not going to see one imaginary root, or you're not going to see 3 imaginary roots. When they come in pairs, that means they come in even numbers, like 2, 4, 6, 8. All right. Now, if 1 plus 7i is a root, well, what else is a root? Okay, well, guess what? It's called the conjugate. And what we do is only change that sign right there that you see. 7 minus I must also be a root. And think about cubic means 3. The degree is 3. So I should have 3 roots. 1, 2, 3. So 1 minus 7i is the other root. All right. Now, a polynomial with degree 5 has 1 real 0. So 1 real 0. They didn't tell if it's irrational or rational. Okay, with a multiplicity of 2. So actually, that happens twice then. And 2 non-real. Non-real means imaginary, by the way. Okay, so I have 2 imaginary. So the question, is the 5th 0 a real 0 or non-real? Well, think about what I set up here. Imaginary roots have to come in pairs and even numbers. That's already an even number. And we only have 1 more root left. All right, so that 1 root, okay, it can't be imaginary. It's got to be real. So I'm going to have a 1 real 0. All right, 1 more real 0. That's what the 5th one is going to be. Because again, these come in pairs. I can't add any more to the imaginary ones. All right, now let's move on. We're going to go to the next page, 249, and look at, are you ready for more? All right, find all the zeros. Now, they give us this and they give us that. So if I see -2 equals 0, what does that mean? Then x plus 2 is a factor. All right, and it's going to cross the x-axis at -2. But let's go graph it. Now, how many roots should I have? I should have 3. All right, so here we go. All right, x cubed minus 2x squared. All right, plus 5x plus 26. All right, right? Yep. All right, now, how many roots should I have? I should have 3. But going back to my graph, how many do I see? I only see 1 at -2. So I have 1 real rational root, all right, at x equals 23. I mean, at x equals -2. So if I'm supposed to have 3 roots in all, what do I know about the other 2? If it doesn't cross, and you can zoom in, make sure, and it doesn't. All right, then they're 2 imaginary. Now, There's one other thing that we haven't covered, okay? And I'm gonna make up that problem right quick. All right, so our last problem right here is we want to name the number and type of roots that this problem has right here. So let's go ahead. We should have 3 roots because the degree is 3. So x cubed plus 5x squared, all right, plus 5x. All right, let's go look at this. I should have 3 roots and look at it. How many roots do I have? All right, I do have 3. Okay, they're all real because I can see it, but there's something special about these, and we haven't come across this yet. They're not imaginary because I can see them. All right, now 0 right here is one real root. One real, and I'm going to rational root. You can write it as a fraction because it can be 0/1 or 0/3. It still equals 0. Now, what about these other two? Now, Desmos is a little misleading because it looks like the decimal ends, but it doesn't. This has been rounded, and the decimal keeps going on without a pattern or anything. These two cannot be written as a fraction. We call these two real, because I can see them, irrational. Irrational means it cannot be written as a fraction. All right. We can see them on the number line, but we can't write them as a fraction. All right. So, and it means it's not going to have factors. All right. So we got a total of 3 here, 2 real irrational roots. Okay. So know the difference between imaginary roots, rational roots, irrational roots. These two you can see. And just like the imaginary roots, irrational roots come in pairs. All right. So know that they can't have any odd numbers. They can't be 3 or just one irrational root. Again, they come in pairs just like the imaginary roots do. The only ones that don't have to come in pairs are the rational roots that I can have any number of those. 1, 2, 3, 4, 5, 6, whatever. All right. Review everything that we talked about with roots and polynomials. You're coming up on your test and make sure you study. Any questions that you have, please make sure you ask your teacher.